Hello, everyone, and this is Abdurrahman Gilal. In today's lecture, we will be learning software process. But before we jump into software process, I would like to just give you a quick recap about software engineering. There are a lot of authors such as Somerville, David Kong, and Pressman. They all are having kind of a belief that like 30 years ago, when people were asked that what is software engineering, that they used to believe that was a Fortran programs. If we are asking them now what is software engineering, they still believe software engineering is a Java code or it's any kind of programming code. But that's what not we learned the other day. Our belief is that software engineering is a discipline, which is basically more. Let me quickly, start writing beside you so that you can see what I'm trying to say. So now we are saying the software engineering, SE, is a discipline which basically do research and do education and they develop application, anything that comes there. That is the part of software engineering. Why do we do this all? We do this all so that we can increase the productivity of software, and then we wanted to improve the quality of software, and then we also wanted to make sure that the software reduces the cost. So reducing the cost, reducing cost, and also we believe that we wanted to, improve the time to market. So these are our fundamental concepts about software engineering these days, that we wanted to make sure that anything we do, like we do research, we do education, or we make any application. So the target is to make sure that the productivity is increased and the quality is enhanced and the cost is reduced and the market time is also reduced. So that's the general perception, that if someone asks you the definition about software engineering. So now we have to see, like some people can ask you that what is a database system focus. So there you have to consider the database focus will be the data, right? Because it is somewhere the center point, right? It's the center is the data. So what we're gonna do here, if we apply SE here, so you're gonna see that our focus will be purely to, do the research to make sure that the data is protected, data is based on a quality, and so many other things related to the data. So something is not the same if I'm talking about database systems, but when I'm saying operating system, so the focus will be changed. Here we are focusing more about the systems, how to say, hardware and their resources, and then managing the resources. So it's more towards different things. So software engineering is actually going to focus not the particular system, but the general principle, that we will be looking and doing everything possibly to increase your productivity, increase your quality, reduce the cost, and time to market, right? So that's the fundamental definition about software engineering. So these days, you cannot mention me any company that or any place that is basically not using software. So almost everything is being used. Every place, I believe that is using software. If they are not using software, so they are either backdated or they are still struggling to bring the software into their process. So it shows me that the software is now, coming everywhere. So now there are, well, how can we make, if the software is for big companies, such as the software is for, oil and gas company, where there will be tens of millions of lines of codes, because they are not the simpler ones, so they are very complex. And believe it or not, the cost of the overall system, if let's say 100,000, then the cost, as per several, scientists, that the cost of software is increasing to 800 to 900 for the IT-based systems. So it's like major part is being, focusing to invest in software, which is of 90% of the cost. So it's not an easy thing. For instance, if you're working on embedded system that has integrated circuits into them, like application specific integrated circuits, some people say AAS, I see, right? So these in these application specific integrated systems are not easy to uh, you know if you already have a software in them and now you want to change the software, so it's going to cost a lot of things over here because the system themselves have been actually integrated with certain constant part. So if you wanted to replace the software of these ASICs, so it's gonna cost you more than what actually you invested for the system. So basically, this is also decreasing the quality of the overall system. So if there is a change, as we discussed, it's also not easy to be done. That if we are considering the software, implementation, once it's done, then how can we make sure? So we need the engineering approach to make sure that software development is just not random or procedural. So it has to follow some specific method. We also believe that the software is not just developed by one person these days. For instance, if I'm saying the software is being developed by one person, so yeah, there is a research that says that one software engineer, let's say software engineer, these days uses or sorry makes or writes simple words that writes almost 50 to 100, source code or line of code. So let's say if I say lines of source code, so just imagine that if you are working on a large software which may have 10,000 lines so to develop. So just imagine that if somebody is even writing 100 line of code, so you have to divide it by 100. So how many days do you need to just finish that thing? And if you have a large scale or medium scale software which has 500 lines of code. So if you go with this way, then how many days do you need? Maybe you need about, I don't know, 20 years or 40 years, something to just finish the software. This is not happening these days. That's why we actually working on teams. So that's also getting a big problem that if you work with team, then you have to make sure that you organize their task and everything nicely. So this is where you need to understand the software process. This is that brings us to software process need. So let's say if I say software development challenges, call for an engineering approach for software development. A software process is required. So a software process defines a series of activities performed to construct a software system. Each activity produces some artifacts which are the input to the others. Each phase has a set of entrance and exit criteria. So that's how we have to first of all understand that this gives us just a series of activities that we have to actually focus. And once every activity may have some artifact that are input to the other activity, this is where our overall system will be actually effective if we go with this way. So now if I say like this is the case, then what are the things that I can actually bring into the consideration of software process? So generally, the big challenges that may occur here, I let me draw them for you. So if I wanted to completely design a software system, so I will go with certain how to say engineering activities or a big things that we have to focus. So let's say now I'm considering large scale or medium scale software. So the first thing is that I have to make sure that I have a complete understanding that what I'm doing. So I have to have a complete conceptualization. So my conceptualization has to be clear enough that I know what I'm actually doing. And then I have to know that this one is not sufficient, that I have conceptualized it. So I have to communicate it with my stakeholder. So stakeholder means anybody who has any interest in the system. So a stakeholder can be a developer, a stakeholder can be a user. So it is something like that. So the communication is also important. And now when I'm saying the communication, then we have to remember the coordination. So if you remember that we discussed, this is a problem, big problem in like how to say, in software project failure. So the software communication, if the communication is weak, then there's something, a big difference. So right now we have articulated three major things that we have to focus to make sure that we, develop a good quality software. Remember the productivity, quality, and cost and time to market. So these three things will be actually, if we can conceptualize nicely, if we can communicate nicely, and if we can coordinate nicely. How can we communicate, conceptualize nicely? We need something clear-cut processes that's there. So we have to define processes and methodologies. So what are the methods that we are going to use to achieve each activity of a process, and how actually they are going to do. So something more on analysis and design, that how I can analyze and how I can design the the concept will help me. So analysis and design is going to be part of the conceptualization. How about communication? So the communication, if we are focusing the verbal communication, that may create problem, right? Because everybody does not understand the same language if the software is big. So there are world-class languages that we can use for the communication. So I would say these are the unified modeling language. So this topic we will discuss later. But let me just quickly give you a recap that this is a kind of a language that actually help us to draw our models, and these models actually follow the standard of this language, and those are every understandable everywhere. So in order to standardize the communication, one should be using UML for the better communication and coordination, right? And let's say there are coordination things that we can discuss, like how can we coordinate, how can we divide the things later on. But we need a lot of tools for that. So we need some tools and techniques that are there that can support us to, make a good teamwork. So when we have proper understanding about what do I mean by teamwork, then it is basically good for us to focus to who can do what, so we can try to focus that how well communication can happen, and how well coordination can happen. So now we are like almost set to go with the process, software process. So here the question arises that what type of process I should focus. So the process may not just focus development, right? Because we are focusing productivity, quality, time, and cost. So many things are here. So what type of process? So basically, there will be software development process that we have to learn, development process. And also, it's one type of process. Then definitely software quality. So software quality process, that is nowadays known as software quality assurance. So means that how actually we assure that quality is achieved. So the third one that can happen is a software project management. Software project management. So these are three things. Now we have to make sure that the productivity can be focus of this. So productivity can be achieved from here if we can improve the software development process, or if we focus the software process. Quality, this second one is for quality, right? And the third one actually covers both, because we are focusing project management. So it is focus is the cost, and time both are here. So these three things are like software development process, of the quality assurance, and of project management. If we perform these processes nicely, then we can achieve the productivity, quality, cost reduction, and time reduction as well. So that's great. So, like overall, now we come to the software development process. So if we have a software development process, so what does it actually do? We have already, give me a second. Yep. Yeah. So for instance, this is kind of a software process that is called the waterfall software process. So I have already some other topics, other videos to explain everything about this, but quickly to see that this waterfall process actually gives us step by step, uh, you know, solutions, then steps that we follow so that we can achieve overall software development. So it goes from system engineering until system maintenance. So how these steps are actually going one by one and how these systems actually can achieve one thing and another, that can be a discussion for the later, but just to give you a quick understanding rightly. So I will say that this one, the first thing we have to make sure that we understand the business need and what business is actually looking for. So, and we should do the feasibility study that is it feasible to make the system or software system for that particular thing, or what are the things that actually come into our consideration or big challenges, and then we go further. So it also requires us so many other things. So this model actually helps us to see. Okay, so each step will ask us to do, like if I am doing some feasibility study here, or sorry about this, feasibility here. And let's say if I am trying to see the business needs here, so I can come up here and I can do the system engineering by considering these things as well. So I'm not focused right now, but Waterfall says if you've done all these things, then you should do the requirement analysis or collect the requirements. So this is not possible if you don't understand the requirements well, then we cannot actually make sure that we can make the software correctly developed, right? This was one of the big problems in software failure, that we do not have clear requirements. So how to collect requirement, we will discuss later. And then once we have the requirements, then we design, as we discussed, that we can use some world-class standards such as UML, so that we can design the software. So we can design detail, we can also make an architecture of it. So once the design is ready, then we go for the coding and unit testing. That means the code should work nicely, and then the code units are perfectly fine. So what is unit? So if there's a big program like this, so there can be small several units. So this is unit number one, for example, or unit number 5 or 6. So when I test this, that if it works well in the system or in the part of the system, so this is called unit testing. But if we have, let's say, 2 units and they wanted to make sure they work together fine, so we call this is called integrity. So like integration testing or something. So this is what we will learn in the next. So if you see the waterfall, so it gives us a step-by-step solutions or steps that are following from one to another one. So as we discussed, the requirement engineering will give in. Once we have requirement collected, then only we can make the design. Then we can develop the code. Then we can go for the integration. Then we go for the testing, and then we go for the maintenance. So this goes like, goes up and down. So this may have some problems. So the problem will be definitely related to, the way it works, right? So because everything has merits and demerits, this is what we have already discussed, right? So we are not just focusing to detail right today, right? So excuse me. Yep. So let me see. Let just quickly give you some merits. So each project is carried out by a pipeline of function team. So we have teams for every different phase of it, and each team is specialized in one function, such as requirement engineering and design and implementation. So we have larger scale. So that is just good for the larger scale projects, right? But it has problems. That's what we're saying. Once we have got this, like, what kind of problem it may face actually. So it is actually, you know, we cannot initiate the later project if the first step is not done. So what I mean from here, so let's say if this part is the software requirement analysis is not done, then design cannot happen. If design is not happen, then coding cannot happen. So you have to wait for one phase to finish to go for the next phase. So this is just a big challenge for such type of methodologies. Yeah, so this may create problems. So like waterfall is good for, let's say, big projects where we have to completely understand, or the project which are mission oriented or they are mission critical. So we have to make sure that everything is clearly defined before we go for the further phases. So definitely it's very much useful, but not for everything. If there's a small project which may and not require too many lines of code, then it is not a good practice to go for the waterfall. So, so now let's say like if I am trying to draw like that, what are the steps of software? Let's say waterfall, like let's say general steps for waterfall, such as requirement engineering. It's the first step, and then it goes for design, and then sorry about this. And then we go for coding and testing. Let's say coding, I just simply go like this, and then we go for testing just like this, and then we go for maintenance. Okay, so these are the steps that, let's say, happens to be in waterfall model. So the first thing is that, each phase will have different specialized people, which is very good. So now how can I apply software quality assurance here? So we know the software development process has these steps. So software quality will verify every step is based on some standard. So this is the verification that we have to ensure that the development activities are carried out correctly. So all of these things will be manually assessed and verified. The first activity of this quality is SQA. So they may have some user input, they may have some other stakeholder input to verify that every phase is actually following the correct way to develop. So a user, I mean, could be expert as well as the nav, so anything. And then once it's done, then we have to make sure that we do the validation. What do I mean from validation is that we should try to use that particular artifact. So the artifact developed from here. So what do I mean from artifact is every phase will produce something as an output, right? So that output could be considered as an artifact, right? At the moment I explain like that way, right? So I will do the validation later once. To ensure that the process is correctly followed, we can use the verification, and to make sure that the process is generating a desired output. So this is what I will make sure through the validation process. So two processes will be carried out, verification and validation. So this will be the validation. This will also be validation, and some part of the things that we always think like there are different types of validation, such as static validation and dynamic validation. So what do I mean from dynamic validation is that this is automated. This is automated. So surely, like there are a lot of how to say artificial intelligent tools these days are happening. They can actually verify the human written language as well. So if it's static, which means that there's some manual processes happening to validate whether the requirement engineer usually produces the requirement specification document. So that requirement specification document, if you do not have artificial intelligence, then you can use static validation to make sure that this is correct, right? And the same things happen for the design and coding. So coding can be actually done if we are making some testing of the coding by using some test oracles. So this could be dynamic kind of validation. So this all process for verification, validation can be considered SQL. This is how we look like. If a waterfall model has these steps, so SQL will be applied. So remember that we do not only have to focus the software development process, but we have to also make sure the software quality is also being achieved during the development process, right? So excuse me, just give me a second to clear this. Yep. Yeah. So there you go. So we have got so many software process models that you should be knowing, and that we can develop some prototype, and then we can also go for how to say, you know what I mean. That excuse me. Yeah. Give me a second because I am trying to adjust my screen here. Yeah. So let's say if I am trying to say the software process model, which means that here I'm not saying simple just waterfall model, which means step by step, but there can be several other models which can help us to develop based on what we are actually trying to develop, right? So there are how I'm gonna start is that when I say prototyping, which means I am trying to say that this model will help me to create a prototype, and that prototype will be an early approximation of final product, and using it to gather feedback from users. But what I mean is that I give this product to the users and how I see the behavior. So there are some non-functional requirements such as security, safety we don't consider right at the moment. For instance, I'm saying, so we just make the functional requirement, what are the functionality of the system, we show to people, and we ask them, is it a correct one? If they say yes, then we go and develop the final one. So it is good to have it so that we can have the feedback every moment before we finalize the product. So we have such as another more process model called evaluationary process model. So evaluation product model is similar to prototyping, but that one basically to emphasize iterative development. So which means that they focus like a loop based, they go one and after to make sure that it involves the initial development of a partial system, which is then refined through multiple iteration to add new features to it. So it does not just let the system added up at one place. So we also got the spiral process, which basically combined iterated development with elements of the waterfall or sequential approach. Basically, it emphasizes risk analysis and management through the development process. Each iteration of a spiral representing a phase of software development lifecycle. So that's this is how it looks like. And then we got unified process model. This one is a very good one that's being used by Microsoft and big companies like that. So they are just not for focusing iterative, but they are incremental, as we discussed about. The other ones, evolutionary or process spiral ones, they are iterative, but this is iterative plus incremental software process model combining. So it is categorized by its use cases to drive design and implement. So we will discuss it later on that what different things can happen into it. So exactly, I'm not going to explain more about these things, but let's say if I say about agile process model, that's very, useful these days. As so many people are working over it because agile process model are iterative and incremental, such as UPM, like Unified Process Model. They are focusing more the customer collaboration. So they let the customer sit along with them, and they sit means do not sit, but let's say they let their input frequent to the system so that they improve. So they do not focus to have the complete set of requirement first, and then we jump out for the development. So this is the effective way these days. A lot of small medium software are being developed using how to say agile process model. So that's how we discussed that every phase will be iterative, and this will be actually So if one phase is completed, so how I design, usually there are so many ways that you can, you know, show the agile process model, but I'm gonna show you this quick one that how it looks like. Okay. So, okay, give me a second. So let's say, so where is my pen? Okay, so let's say if I have this requirement engineering or requirements or design and development, so and testing, let's say, so this all will be one iteration. So this is iteration number one, let's say. And then the same thing will happen for requirement number two. So they will look for the other requirement, design and development, design and development. So they'll be doing like that. So this is iterative and incremental. So each time you go, let's say if it's requirement number one, and this is going to be requirement number two, this is requirement number three, for instance, I'm saying. So the iteration may have to, if it's not complete, so they may repeat the same process. So we will be learning about the agile in a different presentation. So just give you a quick understanding. So at this moment. Yeah, so there are so many agile methods available. The focus is, let's say, extreme programming is one of the very famous method available in agile that uh, uh, you know I was saying that agile is a process model. So in order to achieve the process model, you have to have some methods by which you implement. So and so agile is extreme programming is one of the very famous methods. Okay, so give me a second. Yeah, so I was saying that if I focus, let's say, agile process model, and I'm trying to pick up XP, extreme programming, so how it looks like, let's say. So the first thing that, let's say we do is that called planning. So the processes start from the planning. So what do they mean by planning? Give me a second. I should start from here. Okay, that's okay here. So the planning means that they have everything from the user stories, like for the requirements, what is it specifically they are going to focus, what are the criteria to accept or reject the requirement is implemented or not. So this is first thing that they do. And the second thing, as I say, they do the design. So when they say design here, what I mean from the design, they create some diagrams so that they can show to their developers or communicate with their developers whether these are okay or not. So they sometimes use CRC class responsibility and collaborators, or they can also make some class diagrams or some other things using UML, for instance. So they will be designing something, and once designing is done, then they start doing the coding. Let's say you're using Java or you're using PHP, Python, or anything. So there may be some errors into it, so they do refactoring to it, or they can use some other effective methods to make sure that the code is, you know, develop effectively. For instance, they can implement pair programming, which is one of the technique, which usually in the pair programming of software, two people sit on one screen. So two developers are on one screen. So they have different roles. So this guy is actually coder right at the moment, and this guy is observer. So observer, or you can say how to say the tester at the same time. So a screen is one. This guy may have, sorry about my drawing, keyboard, and he's typing and he's looking. So they can exchange the role later for the next kind of how to say uh, the next I would say next iteration or next requirement. And then they go for testing. Once this is done by this testing is different, but that testing is actually to make sure that whatever requirement was there, did it completely achieve, or was it completely achieved or not. So it may happen that way. So once the testing is done, they can release it. So release the small unit. Let's say this was a big project, so this was a project. So, so what they do is that they have, so let's say 10 requirements to be developed. So, so when they have 10 requirements to be developed, so they have divided the requirement into, let's say, two by two, two requirements, two, and this one also two requirements. So they divided the overall requirements into small chunks of requirements, for instance, and this was first iteration. This is I1, this is I2, this is I3. So each phase that if it goes to I2, so if there is any requirement that has to be actually develop here does not mean that this problem happens in this iteration will be actually done here as well. So the sum code of this will also appear here. The same thing will happen for I3, I4 until IN. So that is how it looks like if we talk about XP, which is a very famous agile method. So there are other methods as well. I believe that if this is good for today's quick presentation, I hope that is not going to be too much for you guys. But in case you got any questions, please do not hesitate to drop me a message. In the next presentation, I will try to explain the different methods available in, let's say, plan-driven type of methodologies or agile development process. Methods. So we will all be discussing those methods. So today I just wanted to give you focus three things. That software engineering is a process by which we actually, or it's not a, is a complete package, which is a research, education, application to increase the productivity of software, to improve the quality of software, reduce the cost and time. And how do we do that? We focus the software development process, we do focus software quality, and then we also focus project management. So three things for this all. Thank you so much, and I wish you all the best, and see you soon again. Take care. Bye bye.